So now under the arithmetic instruction, we need to learn about that subtraction instruction as a SUB, SUI, SBB, SBI. So before going into the much detail of the subtraction instructions used in 8085, first of all we have to understand, we have to learn subtraction using 2's complement method, which is used in 8085 to perform or execute this subtraction instructions. So first of all, we have to understand this subtraction using 2's complement method by taking a very simple number here. So for example, first of all, I am taking here as a two numbers. So one number is p here. So this p number I am taking here as a 10d. 10d means it is their decimal equivalent is 10, or we can say that this is the number I had taken here 10 under the base of 10, or we can say that it is a decimal number. So their hex equivalent we can write in 8-bit, or like their hex equivalent can be written as a 0AH. 0AH. And then I'm considering that second number as a Q. So this Q I am taking here for making the simplicity as a 07H only. So now we need to perform the subtraction as a P minus Q. So P minus Q, how we can write this? We can rewrite this as a P plus under bracket of minus Q. So we have to keep this P number in the normal as it is, and here this minus Q means we have to take the 2's complement of Q, which will be giving the output as a minus Q. So whatever we have the number, if we will take 2's complement, so taking the complement is assigning the sign with the given number. So here we need to add this P with 2's complement of Q, with 2's complement of Q. So 2's complement of Q will give minus Q, which is added with P, ultimately perform P minus Q. So here we have to see that how to do this. So this P, how we can write here? This P can be written P in the hex it is 0AH, and under the binary representation in 8-bit this can be written here as a 0 0 0 0, and A is 10, so this can be written here as a 1 0 1 0. Now this Q, so whatever we are having here Q, let's say this Q is represented in terms of 8-bit as a 0 0 0 0, and this is 0 1 1. So Q is basically 07H. So now how to write down their minus Q? So there is two methods. One, first of all, we have to find out the 2's complement of this Q. It means first you take 1's complement. So 1's complement of Q, 1's complement of Q can be given here as a, all this 0 will change to 1 and 1 will change to 0, and again at their LSB position add here 1. So now it will become here 2's complement. So this 0 plus 1 is 1 0 0 1, then this 1 1 1 1. So this is called here as a 2's complement of Q. 2's complement of Q. So this is with the help of 1's complement. Directly also we can find out their 2's complement of the given binary representation. So how to perform that? We have to check it the first non-zero. First non-zero means here in this case this Q is having the first non-zero at this position itself. So write this number as it is here 1. So we can write it here as a 1. Now rest of the bits, how it can be represented? That it will interchange 1 to 0 and 0 to 1. So here this 1 1 can be written here as a 0 0. Then remaining 0 it can be written here as a 1 1 1. So now this is also called 2's complement of Q. So this pattern both is same. Which one is suitable for you? You can opt whether you can find out this 2's complement with the help of 1's complement, then follow this method. If you want to find out the directly representation of Q, of finding the 2's complement of Q, then you can follow this method directly. So now this is giving the representation of this Q, like finding this 2's complement of Q. So this is 2's complement of Q here, whatever we got, it means it is representing what values? It is representing minus Q. So whatever we got it, the representation of minus Q, or finding the 2's complement of Q, that should be added with this P. So here, now we need to add these values here. So we got it here. Q is equal to minus 07H now. So this should be added here. So whenever you will add this we have to write it first. 1, 1, 1, 1. Then 1, 0, 0, 1. So now you can add this P and Q. So it is giving the subtraction of P and Q here. So 0 plus 1, this is giving here as a 1. Then 1 plus 0, it is 1. 0 plus 0, it is 0. 1 plus 1, it is sum 0 carry 1. So again 1 plus 1, here it will be sum 0 carry 1. Again 1 0 1, here this sum will be 1 carry 1. So 1 0 1, sum will be 0 carry 1. So 1 0 1, sum will be 0 carry 1. So this is giving here in this case, but here it is showing that if their MSB position is 0, or as a result of the subtraction, if their MSB value is 0, it means D7 position value is 0. This is indicating that the result, whatever we obtained, it is positive. As like this P value in decimal we had taken 10 and Q is 7, either in the decimal or hex. So this subtraction will produce that 03H or 03 in the decimal. So here result is positive. So what will perform here? In the microprocessor, how the flags will be updated. So this carry will be complemented. Whatever we got this carry here as a 1 in 8085, if the carry is coming 1 in 8085, it is making to 0. Whenever it is performing this 2's complement subtraction, or whenever it is executing 2's complement, whenever it is executing this subtraction interaction, so by default internally it is using 2's complement method to perform the subtraction. So microprocessor will do that. Whatever carry result will obtain, it will be complemented as a final result. So here this will be complemented here. Complement carry. So complement carry means this carry here it is 1. Now it will become here as a 0, with the remaining result bit will be same, as like remaining result bit will be 0 0 0 0 0 0 1 1. So here it is giving the result as a 03H, which is going to be stored into the accumulator. So as we know that by default in all the arithmetic instruction, one operand is holded by the accumulator itself, and another one we have to specify in the instruction either through the register content or through the memory content or with the immediate 8-bit of data also. So here this result will be stored into the accumulator as a 03H, and if we will check it, the flag status, how it will be. So here this sign bit is 0, so this sign will be 0 here. Then we have to check it about that 0 flag. So this result is non-zero, so this 0 flag will be also reset. Then after this we have auxiliary carry. So auxiliary carry is generated here as like this. So auxiliary carry bit will be 1. Parity bit will be, like if you see in the result, there are even number of 1. So parity bit will be even, so that will be 1. And carry bit here it will be 0. So whatever after complement is the status of the carry bit, that is going to be updated as a effect over the flag. So this is the main part which you have to consider. Whenever we are performing these two's complement subtraction method is used, and that is only used by default in 8085. Then whenever we are performing the analysis as a subtraction, then we have to check it while doing the operation. If the carry bit is 1, then as a final result or as a final effect over the carry, it should be complemented, then it will be 0. If the carry is coming 0, it means it is going to be complemented as a 1, and that 1 will show the reflection over this carry flag. So that must have to take care while doing the analysis of your program, or whenever you are doing that learning about the instruction also. So this we had taken when P is greater than Q. Here in this case we had learned that P is greater than Q. It means this P minus Q will be greater than 0. It means the result will be positive. Now we have to learn if P is lesser than Q, then how the situation will happen. That we are learning here. So now in this case, what we are doing the reverse. As like I am taking this P number as a 07. I am taking here considering P as a 07 and Q as a 10 in decimal, or we can say that 0A in terms of hex number. This is also, this 07 will be same in hexadecimal as well as in the decimal also. So now we have to perform the operation as a P minus Q. So first of all, whenever we are going to perform this P minus Q, so that is the subtraction result will be providing here. So P minus Q means P is here as a 7 and Q is 10 in decimal I am talking. So here this result will be minus 3 in decimal. Minus 3 in decimal. So how it is going to perform here in 8085, that we have to learn first. So here this we need to perform P minus Q. It means P plus of minus Q. So we need to find out the 2's complement of Q's first, and that should be added with this P. So that is giving the result as a P minus Q. So now here we have to see this Q has given as a 10. So we can write this like in hex it is 0A. So this 0A in binary it can be written in 8-bit as like 0, 0, 0, 0, and A can be written 1, 0, 1, 0. So now here we need to find out this minus Q. So minus Q means it will become the representation of minus 0AH. So how it will be? We can directly do that. First of all, we have to consider first non-zero. So this is the first position, it is 0. So this will be comping as it is 0. Now the first non-zero is this one. So this will be also comping as it is. Now after the first non-zero values, whatever is the bit there, we have to interchange 0 to 1 or 1 to 0 to find out their 2's complement. So this 0 will be here 1, this 1 will be 0, and remaining zeros we can write it here as a 1's. So now this is the 2's complement of Q. This is the value, whatever we got it, this is called the 2's complement of Q, or representation of minus Q. It means minus 0AH. So now we can write this first of all P. So P can be written here. P is equal to 07H. So this can be written 0, 0, 0, 0, and 7 can be written as 0, 111. Now this minus Q. So minus Q is what? Minus Q is simply minus of 0AH, and this should be here 1, 1, 1, then 0, 1, 1, 0. So now adding these two 8-bit numbers is giving the result of P minus Q here. So first position 1 plus 0, it will be 1 only. Second position 1 plus 1, some bit will be 0, carry bit will be 1. In third position 1 1 1, so sum will be 1, carry will be 1. So 1 0 0, this will be 1 here. And again this fifth position is a 0 plus 1, it is 1. Then again next 0 plus 1, it is 1. 0 plus 1, it is 1. 0 plus 1, it is 1. And the carry bit is not generated from this 8th position or from this D7 position. As I told, here if you see that this sign bit from this D7, it is giving here 1. It means it is saying result is negative. So as an impact of that, carry bit also should be updated. It means this carry bit will be updating as a result of this operation to the flag of the 8085. It will be complementing this. So this bit will be complementing. So complement carry with the same remaining bit. Complement carry. So this carry bit now it will become here as a 1 with remaining bits, like whatever is the result bit it is showing, it should be as it is. So here it is 1 1 1 1 1 1 1 0 1. So this is giving here as a F. This is here F, and this is what? 1 0 1 0 means what? This is 8 plus 4 12, 12 plus 1 it is 13. So 13 means like 10 is A, then 11 is B, 12 is C, and 13 is D. So this will be here D. So this is storing into the accumulator as a FDH. But here what I told, in decimal it should be giving that -3. Here this is giving FD. So if you'll see that this MSB bit is 1, it is showing that the result is in 2's complement form, or even after execution of the subtraction instruction. If this carry bit is showing here 1, it means it is giving the result stored into the accumulator, it is in 2's complement format. So here if you want to find out their magnitude, then how to do that? This 4 times 1, then again 1 1 0 1, which is showing here D. So now if this is already in the 2's complement format, if you will take it back there again 2's complement, then that is giving their magnitude. So here their MSB bit is 1, it means their sign is negative. Now if we take their 2's complement, so how it will be? 1, then this 0 will change to 1, this 0 will change to 1, and now remaining ones will be changed to 0. So this is giving here as a 0 3. So this is giving here as a 0 3H, or this can be treated as a -0.3 into the decimal also, because 0 to 9 the representation of a number in decimal or hexadecimal, it will be same, because 0 to 9 is the valid decimal digits as well as hexadecimal digit also. But from A onwards it is not having that valid BCD, it is valid hexadecimal only. So here this should be our expected result here. But the major point is, whatever is the effect here on the carry after performing this operation internally, this microprocessor will take the complement of this carry bit status. So as a result of that, this should be the status over the carry. So here this will give you the result, that microprocessor will give you the result in hexadecimal or complemented form. So as a result you will get this FDH here. So that is the representation of -03H. This is the representation of -03H, or even this is the representation of -03H or -03 under the decimal also. So here our expectation has meted. Only the point here is we have to be careful while taking the status over the carry. So in the exam they might be asking, after performing this operation, what should be the status of carry? We should not say 0 here. So now as per the result I am going to write their flag status in 8085. So here sign bit should be 1. So sign will be 1. Then result is non-zero. So this 0 flag will be 0. After then from this auxiliary carry there is no carry generated at from the fourth stage. So that is the reason this auxiliary carry will be also 0 only. Now here in this result, as per this result here, if we'll count number of ones, it is showing here 7. So this parity bit is also here as a odd parity 0, and carry bit it should be 1. So carry should be updated after the complementing their carry bit from this operation, not from this point here. That is the main point we need to focus here. So here carry bit is 1. So these will be the status of the flag registers after performing this operation over there. So here I hope you understand how to perform the subtraction by using 2's complement method. In this case we had seen this P is lesser than Q. So this is giving P minus Q is lesser than 0. It means the result is negative. That is verified with this MSB bit as a 1, and the same effect it is showing over this carry also. So here this is the representation of minus 03 as a subtraction result. So this is the representation of this minus 03 under the decimal or hexadecimal. So I hope you understand this subtraction operation by using 2's complement method even for P greater than Q as well as for P lesser than Q. So this subtraction method will be used in doing the analysis of the subtraction instructions whatever we are going to use in 8085 microprocessor. So further we'll discuss in the next videos for the subtraction instruction. I hope you understand up to this very well.